Our solar system is home to many wonders, and among them is Venus, often called Earth's twin. Shrouded in thick clouds, Venus has long held secrets about its surface. Recent discoveries have unveiled a world teeming with volcanic activity. A landscape sculpted by lava flows far more extensive than we ever imagined. These findings have ignited our curiosity, offering tantalizing clues about the planet's evolution and the potential for life in the most extreme environments. For decades, we have known that Venus is a world shaped by volcanoes. However, the extent of its volcanic activity remained a mystery. The thick atmosphere, a dense shroud of carbon dioxide, obscured our view of the surface. Radar observations hinted at volcanic features, but it wasn't until recently that we had clear evidence of active lava flows shaping the planet's surface. The discovery of these lava flows was a major breakthrough in our understanding of Venus. It painted a picture of a planet far more active than previously thought, a world where molten rock sculpts the landscape on a massive scale. These findings have forced us to re-evaluate our assumptions about Venus and its evolution, prompting a wave of new questions about the forces that have shaped this enigmatic world. Unveiling the secrets of Venus's surface, hidden beneath its dense atmosphere, has been a major challenge for scientists. The thick clouds, composed primarily of carbon dioxide, are highly reflective, making it impossible to see the surface with ordinary telescopes. To penetrate this veil, scientists turned to radar technology, using radio waves to map the planet's topography. Radar observations revealed a world scarred by volcanoes, with vast plains of solidified lava flows, towering shield volcanoes, and intricate networks of volcanic fractures. However, these early observations could not determine whether the volcanoes were still active. It wasn't until recent missions, equipped with more advanced radar systems, that we could detect the telltale signs of recent lava flows. By comparing radar images taken years apart, scientists noticed subtle changes in the surface features, indicating that some of the lava flows were very young, geologically speaking. These observations provided the first conclusive evidence that Venus is not a geologically dead world, but rather a dynamic planet with ongoing volcanic activity. This discovery sparked a renewed interest in Venus, prompting scientists to delve deeper into its geological history and its potential for harboring life. The discovery of active volcanism on Venus has prompted fascinating comparisons with our own planet, Earth. Both planets are remarkably similar in size and composition, suggesting that they shared a similar origin in the early solar system. However, they have evolved along vastly different paths, resulting in two drastically different worlds. Understanding why these two planets diverge so dramatically is a key question in planetary science. On Earth, volcanic activity is a fundamental geological process, playing a crucial role in plate tectonics, the slow movement of continents across the planet's surface. Volcanoes are often found along the boundaries of these tectonic plates, where molten rock from the Earth's mantle rises to the surface. This process has shaped Earth's continents, oceans, and atmosphere over billions of years. Venus, on the other hand, does not appear to have plate tectonics. Its surface is one continuous crust, without the distinct plates that characterize Earth. However, the discovery of widespread volcanism on Venus suggests that its interior is still geologically active, even without plate tectonics. This raises intriguing questions about how Venus loses its internal heat and what mechanisms drive its volcanic activity. The volcanic features on Venus are not just isolated occurrences, they form vast interconnected networks that span the planet's surface. These networks, known as volcanic rises, are massive dome-shaped structures that can be hundreds of kilometers wide and several kilometers high. They are thought to be formed by plumes of hot material rising from deep within Venus's mantle, similar to the Hawaiian Islands on Earth. These volcanic rises are often surrounded by extensive lava flows, radiating outwards like spokes on a wheel. These flows can be incredibly long, stretching for hundreds or even thousands of kilometers across the Venusian plains. The sheer scale of these volcanic features is a testament to the intense geological activity that has shaped Venus over billions of years. The discovery of these vast volcanic networks has forced us to rethink our understanding of Venus's geological evolution. It suggests that the planet's surface is constantly being renewed by volcanic activity, erasing older features and creating new ones. This process of volcanic resurfacing may be the reason why Venus's surface appears relatively young, with fewer impact craters than one might expect for a planet of its age. The extreme conditions on Venus, with its scorching temperatures and crushing atmospheric pressure, might seem inhospitable to life as we know it. However, the discovery of active volcanism raises intriguing possibilities about the potential for extremophiles, organisms that thrive in environments considered extreme by human standards. On Earth, we find life in the most unexpected places, from the depths of the oceans to the boiling hot springs of Yellowstone National Park. Volcanic environments, even in their extremes, can provide the necessary ingredients for life. Volcanic activity releases heat, chemicals, and nutrients into the environment, creating potential energy sources for microorganisms. On Earth, we find extremophiles thriving around hydrothermal vents, cracks in the ocean floor where superheated water spews from the Earth's interior. Could similar environments exist on Venus, perhaps in its distant past when conditions were less extreme? While the surface of Venus is currently too hot for liquid water, scientists believe that the planet may have once had oceans of its own. If so, ancient volcanic environments, similar to Earth's hydrothermal vents, could have provided havens for life to emerge and evolve. Even today, the Venusian atmosphere, with its thick layers of clouds, might hold clues to the planet's past habitability and the potential for microbial life. The recent discoveries on Venus have only deepened our fascination with this enigmatic world. To further unravel its secrets, space agencies around the world are planning a new generation of missions to Venus, equipped with cutting-edge instruments designed to study the planet's atmosphere, surface, and interior in unprecedented detail. These missions will use a variety of techniques to probe Venus's mysteries. Orbiters will peer through the clouds with advanced radar systems, creating high-resolution maps of the surface and searching for signs of active volcanism. Atmospheric probes will descend through the thick atmosphere, measuring its composition and searching for chemical signatures that could hint at past or present life. And perhaps one day landers will touch down on the searing hot surface, collecting samples and beaming back data that could revolutionize our understanding of this fascinating planet. Venus, once shrouded in mystery, is finally beginning to reveal its secrets. As we continue to explore our celestial neighbor, we can expect even more surprises, challenging our assumptions and expanding our understanding of the vast diversity of planets in our solar system and beyond. The journey to understand Venus is far from over, and the discoveries yet to come promise to be as groundbreaking as those that have already captivated our imagination.